So guys, welcome to a new tutorial by Nyjo FX. Today I'm going to work on something really simple, and I'm talking about a feeling, about for example a glass feeling or maybe a cup of tea feeling. And that's a really simple thing, but there are some stuff that needs to be known to create the right setup. So today we are going to simulate this one. And I hope it will be really useful for a lot of artists. And soon we are going to post more tutorials about LiquiGen, and we are also going to release the LiquiGen Inception course really soon in April. So let's start working on this new tutorial by Nyjo FX. So, sorry, we done something similar when we prepared the orange juice setup. But maybe it will be interesting to see a really simple way to do it when we are talking about, for example, a glass of water, or maybe we are talking about a cup of coffee or something like that. So the first thing is that actually it's a little bit more complex to feel something using LiquiGen. So there are some tricks you can use. So let's make a test setup in a really simple way. We are not going to use this primitive, but I'm going to use something that was sent me by a user, and it's essentially a user that was trying to do something like that, but there was some problem. So actually I'm preparing this tutorial for him and for all the other artists that like to find a really simple way to feel something using LiquiGen. So I prepared a mesh that is similar to the one he sent me, but it's in Alembic file format. So it's loading obviously, but you know, usually the imported mesh is really big, so we have to take care about the scaling. And let's say we have no animation, so let's say that we go to something 10 times smaller. Usually you can do everything also using big scale fluid, it's not a problem. So actually we are going to do something with this setup. Let's go to have maybe a uniform color, so we don't need to have something done in a different way. Let's say that the color for the light is similar to the sun, and then I like to have a little bit more sun, and we get to have the sun here and maybe higher light angle. So that's the setup we're going to use, and we have also the ground that is a little bit darker. You can use also the HDR map, it's not a problem. So actually what we need is essentially creating the feeling. So you know, we have the primitive there that will be our emitter. So we're going to move it. If we press R, you see that it needs to be tweaked. Okay. And then we say to the collider mesh that it's not visible, so we are able to see what's going on inside. If we press spacebar, you see that it's simulating, but the first thing we have a really big splash here. So about the collider, let's say that it's again visible. We move it just a little bit. And then we raise the resolution about the meshing voxelization, and then we are back to simulate something. We have still stuff that are going outside, but it is not a problem. We'll take care about it in a few. So the emitter is a sphere, but I like to have something that is smaller, so let's go for 0.5. And about the emission, let's say that we have a different emission. So it's continuous, but we have no life for the particles. And we have an higher volume of water that is falling down. So you see that we have something like that. Okay. So let's start playing with something else about the simulation. We go to a lower resolution, let's say 0.08 for the voxel, and obviously if our mesh is double, it's going to use a double resolution for the simulation we have here. And then we go to have two stop steps. Press spacebar. It's a little bit more precise than before, but we have still stuff that are going outside. Okay, it's essentially that's not a big problem for the moment. So we can take care about it in a few. First of all, we can add a drag force to generate a little bit of dragging. Let's move the force here. And the drag force will be limited, so let's go for something that is really small. So 0.05. Okay, obviously we are losing partially the acceleration, so in this way you see that we are essentially solving the problem without any efforts. Okay? By the way, let's get to see just the points. I like to see just the particles. And you see that the particles are moving inside the fluid, but it takes time to fill the mesh, and that's a known situation. So usually we are going to help it to achieve the right result. By the way, before everything, we can go back again to the simulation, and we can tweak a little bit the stuff we have here. And first of all, I like to have something that is in between the peak and the flip. So we go for 50% R, and now we'll see how it behaves. You see that it's behaving in a different way because obviously it's not completely a flip fluid, and that's better. So it's less splashy than before. But again, it takes a lot of time to fill the mesh. So we can use some tricks, but before moving to the tricks, I like to simulate something. We need for sure more particles, maximum particles. So let's say 50 minutes for a moment, because we need a lot of particles to cover everything. And about the voxel, okay, I think we can go lower for the moment. So we'll have more memory free. Okay. Okay, nice. So the idea is that we are going to use essentially another primitive to generate the fluid, to help us to generate the fluid. You can use a little bit of compensation about the compression and the decompression. So if we try to go for something like that, maybe we can have something that can work in a different way about the decompression, you see, but we are losing volume. So if we go higher, we'll see in a better way what's going on. You see that the fluid is working nicely, but you see that we have something that is less heavy. If we remove completely the compression, you see that we have this kind of fluid. So let's say that this one is, oh sorry, this one is right. Let's say that this one is to 0 and we have no compression compensation too. And you see that we have still something that is not bad, but we need something to be able to fill the volume, because in this way it is really really slow and it's not able to generate the right amount of fluid we need. So let's go back to have a little bit of compensation for the compression, and then the possibility is to generate essentially a second emitter. That's the idea. So let's say that this one is visible again. Okay. And we are going to add a second emitter, and this one is, for example, a cylinder, because in this way we are going to, let's say that this one is bigger. Okay, obviously now it's too big. Okay, we can go lower because this one needs to stay inside. That needs to be inside the bottle. So it needs to be smaller than what we have. So let's say 4 meters. And just to be sure, we go up, and let's say that it's smaller, so it will be able to generate less particles. So now we see it. So let's do something like that. And then back, it's not visible, and also the collider is not visible. Press R. So then you see that what's going on. This one is helping to filling the glass, but I like to do something. We need to be sure that this one is not working at the beginning. So let's say that it's animated. It is set to off, and then R, and then space, and you see it is starting to have the water inside. And then when we have a little bit of water, let's say that we can have the second one maybe around, let's say for example there. We say that this one is active, space bar. Okay, we can have it later. So we have the fluid that is going inside, then it starts to have more water. If you like, this one can be later, it's not a problem. So you see that we have the big splash, and then we are starting to have more and more fluid inside. Okay, we can save the scene. Let's say glass filling. Okay, so I like to generate some kind of turbulence to make more movement inside. So to do something like that, we can have a force. We go for a turbulence, and this turbulence can be nice to, let's say that is, let's try in this way, and let's see what's going on. Okay, we have a lot of turbulence, you see, so it's going to generate a really turbulent fluid. So the idea is to use a mask. So we are going to say that we like to have the turbulence inside here, and then we'll have no more turbulence. So let's say show mask force. So you see that's the sphere. And then the sphere will be bigger, let's say, for example, 5. And then we get to move it here. You can be more precise if you like, it's not a problem. Let's say maybe something like that. And we can have a little bit of fall off. Let's say 0.2. And let's say that is no visible. Okay, so in this way we have the turbulence here and not turbulence here. Okay, so then we have just to take care about the scaling, and I like to have a bigger scale. So maybe we can have something around 20, You know, in this way we are just generating a lot of turbulence over the water. And let's say that this one is high, the amplitude, just to see how it works. And I like to have also a little bit of animation over the noise. R and then spacebar again. Okay, so you see that we have a really big noise inside. It's obviously too much. So we go really low to 1, R, space. Then it's splashing. We have still some small stuff that are going outside, but if we need, we can create essentially a drain to remove the particles that are going away. Okay, so if we like to create a drain, we can have drain. Let's make the collider visible, and then we do something really simple for the moment. Let's say that this one is essentially a cylinder. It's, let's say, 5, and let's say that the drain is visible, and we set this one inside. To be sure, we go a little bit bigger, and it needs to be higher. Let's say 20, 30, so that's really high, but we have to make it a little bit bigger. Okay, it should work. Let's remove the collider here. The drain too needs to be not visible. Okay, we have to invert the shape. So now it works inside, and if some particles goes away, will be drained from the simulation. Okay, R, Control S to save. So, sorry, we can do something more, and that's essentially generating a little bit of, you know, of twisting inside. So we can do it using a force line. And the force line, let's say that we are going to have a twist. Okay, you see that it's crashing because we have the force that needs to be in the right position. So we need to move it. And we can have something like that. Okay, let's show no collider, spacebar, and you see that we have this big twisting inside. So I think we can go to have the shape mask for the line 2, and this way you see that it's working, and then we have the twist over there. So the volume is twisting around in this way, and what we can do is, if you like, you can have a little bit of fall off also for the line, but in this case we can essentially have a lower energy for the twist. Control S to save, R, space. So in this way we'll have a little bit of twisting and the noise, and then we'll have just the filling up of the water. If we are going to have a little bit less drag, let's double check. And if you like to speed up, obviously you can have the flow rate that will goes up. So the idea is that, let's say we can do a test. Let's say that we go to split this one. We have another emitter is connected over here, and this one is here and disconnected from this one. So actually it works in the same way. You see, we split the emitter, but essentially it works in the same way. Okay, so if we like, we can essentially saying that we have an higher energy in the emitter inside. We can have back, for example, the strength to 0.05, and here we can say that, for example, we have 20. You will see that we have a lot of more particles that are generated inside. So the idea is that, for example, you can use this one later if you like, but again, it is up to you to decide how you like to have the simulation. So what I can say is that we have the possibility to have this one is simulated in 10 frames. Obviously, we can do it faster if we are going to emit more particles, but on the other side we can try to see the mesh what we have at the moment, and the liquid appearance, let's say that we have less absorption and a little bit of roughness. So R space you can find a better timing for the moment when we have the second emitter that is going up. By the way, then you can decide, for example, that maybe at frame 600 or maybe 700 or whatever else, the emission will be stopped. So let's say, for example, at frame 600. So we have the possibility to say that the emission is completely animated, so it is set to on here, and then at frame 600 it is set to off, and back at 0 this one is animated to, it is set to on, and then at frame 600 it is set to off. Okay, so if we go to simulate, you will see that we have the fluid that is going up. You see that we are going to cover again. We can tweak the timing to achieve a better result for the fluid at the beginning, or maybe we can add more water emission for the first emitter here. So now we are going to take care about the stuff here. So let's say with a comment that here we have the forces, and here we have the emitters. Now you will see that it is going to stop the emission, you see. Also the other one inside is stopped, and then it will take obviously some frames to finishing to fill everything. If you like, you can animate also the forces for the turbulence and the line here, so you will have no forces over there anymore. As you see that it is essentially working. So Control S. So let's say that this one is renamed to emitter top, and this one is renamed to emitter bottom, so we know what we are talking about. And this one is shape emit top, and this one shape emit bottom. Okay, that's our collider. So we have essentially everything. Control S. If you like, obviously you can render this one in a better way. We have the possibility to add more samples here inside the viewport. or if you like, you can use the pot tracer. It's not so fast here because I'm using a 3090, but it is nice to see how it works. So let's stop it there, Ctrl T, and you see that we have a really nice fluid. It is going to calculate also the caustics. So if you like, you can decide. If I go to remove the denoiser, obviously it's more precise. But you know, in this way you are going to have something that is nicer to be seen, and it is going to generate the caustics in a really nice way. By the way, again, let's go back to something that is renderable in a simpler way. And I'd like to see if we can do something to our mesh. Okay, let's try to have a little bit more smoothing, and let's double check what we can do with actual fluid mesh. We can try also to have something that is higher resolution. We can try with 0.0, let's try 65. We have to see if we have enough memory for the particles, but you see that we have still enough memory to do it. And again, you are completely free to simulate as you prefer. If you like, you can have a little bit, when you see that when we have a more precise resolution, we have maybe a little bit more splashy. You can work on the peak flip ratio, or we can also add a little bit of thickness. Maybe in this way we are going to avoid the splashy effects we had before. If you like, the noise can be bigger or smaller. You can find the best compromise for your scene. Okay, so R, Ctrl S, and then we can go to render it, but I like to see what we have here in the camera. Okay, so the camera needs to be tweaked. So this camera is for a render, and we go. Let's see. Okay. We're not going to use the path tracer for the render, so let's stay in this way. Ctrl S, I go to render some frames, let's say maybe 600 frames. So the idea is to export image. We say render viewport. It's a sequence. Let's go for not so high resolution, and let's say maybe 700 frames. And the directory, I'm going to use this one, so preview. Let's call this one glass of water. And I like to have 4 number for the file format and export. So you see that's the result, and based on what we see actually, you see that that's not bad, but then we have a really big pushing for the water that is emitted, and then we have the final result. I think we can do something, and something is essentially that we have here is one that is starting essentially here, you know. This frame is the 377. So we can animate this one and say that it's 0, and maybe at frame 500 is 20. In this way, we should see a pushing in the simulation. So we see the water that is falling, then this one will start. We have for sure to, let's say that also this one has more water. So we have more water falling down. Then this one is starting, is less visible than before. And then it starts to push more the water, you know? Let's try to do something more about the top. We have still more water falling down. Okay, you see it's filling more the simulation. Then we have the other one that is pushing inside, and then step by step it will rise up. Maybe something that needs then to be done is to move away this one, so we'll have more water that is coming inside. So let's say maybe we have let's say until frame 700 we can go for something like that, and we do the same for this one. So essentially we're near to have the same animation there, and we can try to export again, but we need more frames. Let's say maybe 800. Control S to save, and we are going to export again everything. So let's double check this new setup if it works in a better way. You see that then we have this pushing, and again this one can be done. We have a little bit of falling down stuff that are going outside due to the simulation. You see that we have something that is going outside. We can double check this one. It is related to the pushing on the simulation, so maybe we can say that this one, when he's here, at the beginning is 0, and then here is maybe 10, and we can double check the simulation together. So you see that it's working fine. Then we should see that it's rising up, and we can have lower water with this one. It's not a problem. We have the emission. Okay, you see that the fluid should rise up. It is rising up a little bit slower, and then that's better because we have not the big push we had before. So I think that's not bad. And then we'll have the simulation that will be stopped at frame 700. So let's go back in the camera. Obviously, depending on the glass or the cup you are trying to simulate, you have to take care about the timing, you have to take care about how many water is emitted and stuff like that. That's just a way. As always, there are many ways to simulate the same thing, but I think this one can be useful to understand which are the problems you can encounter with the simulation. Okay? So let's stop, and guys, that's all. We'll see really soon again because we have to finalize the series about Unreal and LiquiGen. We have to see the JSON exporting stuff. So thanks again, and bye.